Okay, so this question here is about applying Le Chatelier's principle to this situation. And before we do anything, let's just write out the equation that we've got. And let's add some information to the equation. So we're told in the question that the forward direction is endothermic. That means it takes in heat energy, and that means it's going to make the surroundings feel cooler. That makes the backward reaction be exothermic, and that means it's going to release heat energy, and that causes surroundings to get hotter. And then if we look at the number of moles, we've got 1 mole of methane and 2 of water, so we've got 3 moles here. And on this side, we've got 4 moles and 1 mole here, so we've got 5 moles here. And because there's more moles, the higher pressure is this side. This side's got fewer moles, and therefore this is the low pressure. So now we've got that, let's just check what the question wants us to do. So it wants us to explain what effect there would be on attainment. Now remember, when we talk about attainment, we're actually talking here about the ideas to do with particle theory, rates of reaction. So we've got to be thinking in those terms. And the equilibrium yield. So here we are using Le Chatelier's principle. And we're trying to do it in 2 conditions. One is to do high temperature, and one is to do a lower pressure. So let's do temperature first. So down here, what we're going to do is we are going to try and increase the temperature. Okay, so we are going to try and increase the temperature. Let's do from an equilibrium perspective first. So equilibrium yield. And then we'll do the attainment separately. So equilibrium yield, and we're looking at increasing the temperature. So according to Le Chatelier, if we increase the temperature, Le Chatelier's principle says it will try and lower the temperature. So it's going to try and lower the temp. Now to lower the temperature, the equilibrium is going to move to the right because that is cooler, because this reaction is endothermic. So here we can say, next in this statement, is that the equilibrium will move to the right. The reaction is endothermic in that direction. And if we go to the right, then what we're going to end up with here is we're going to end up with more hydrogen being produced. So here we can say that more H2 will be produced. So that's a good thing to do. If we now over here, a little separation, if we now look at attainment yield, so how much of this attainment equilibrium was attainment of equilibrium. So attainment of equilibrium. So if we have a higher temperature, then what we know is that the particles have more energy. And if the particles got more energy, they will move more, and therefore there is more chance of successful collisions, and that means the attainment will be set up more quickly. So the attainment of the equilibrium will be faster. Okay, let's have a look. So that's explained those two. The next situation they wanted us to talk about was the pressure. So I'm going to come down here and we're going to do the pressure. And what they were trying to do in this situation is they want it to go at a lower pressure of 10. So here we're going to say pressure is going to be lower. And again, if we do the same formats, we're going to do equilibrium yield first. So we have got equilibrium yield. So let's do the first step. And according to Le Chatelier's principle, if we lower the pressure, then what will happen is the reaction will try and increase the pressure. The reaction will increase the pressure. And if we're going to increase the pressure, let's go back up to our equation. So if we're going to increase the pressure, then what this reaction will try and do is the reaction is going to try and move to the right, because this side has got the high pressure because there's more moles on this side. So we can then say that the equilibrium will move to the right. There are more moles on this side. And what happened then to hydrogen is hydrogen will increase. The amount of hydrogen is going to increase. If we then look at attainment of the equilibrium, so attainment to the equilibrium, and if we have a lower pressure, then that means there are going to be less collisions because the molecules are going to be further apart. So here we can say that the molecules are further apart. Therefore, there are going to be, let's change that the other way around. There will then be less chance of successful collisions. There's less chance of successful collisions. So the attainment of the equilibrium will be longer. It'll take longer to reach that equilibrium.